Um, Nicolle Cysneiros is going to tell us about graph databases. Please help me give her a warm welcome.
Thank you. Hello, guys. Can you hear me fine? A little louder? Okay, sorry. Sorry if I sound a little bit nervous. It's because I am. This is my first PyCon, so I'm really excited to be here. Thank you all for receiving me. It's been amazing, this experience. Before I've been to EuroPython last year in Rimini. I don't know if anyone here was there. No? Probably not, it's really far. But it was amazing too, and I gave the same talk, and I always like to introduce graph databases to people. Always find someone in the audience that could use it in their application. Um, has anyone here heard about graph databases? Please show me your hands. Oh, a lot of people, that's great. It's not like a new thing anymore, it's like old news, I guess. But yeah, I want to talk to you about graph databases and how these two can help you with your data relationships in your application. And my name is Nicolle Cysneiros, if everyone is wondering. So who am I? I am a full stack developer at LabCodes. And I work mainly with Python and JavaScript. We develop web solutions for our clients. I'm also I really like the community. That's why we are all here, I guess. So I'm a member of the Python user group in Pernambuco, and I'm also PyLadies in Recife. I also helped organize Jungle Girls in my city. It was really amazing, the best experience ever. We helped a lot of girls to get into coding. It was really cool. And LabCodes is the company that I work for. It's a software studio from Recife. And we work, as I said before, we work with Python, JavaScript. We also work with Elasticsearch, some of the backend technologies. And we work bringing solutions to our clients. We are a software studio, so our clients come up to us with a problem, and we work with them through all the process, since designing the solution and actually delivering it. That's our job. And I work with these real cute, nice people that I miss so much already. And LabCodes actually came from the community. It was born in one of the PyCons in Brazil. It was born in one of the PyCons in Brazil. And we also like to give back, so we are always at PyCons in Brazil. This is the second time that Renato is here at PyCon. We went to Python. We are going to Jungle Europe also, so we also always like to get into the community. It's really cool. So I talked a lot about Recife, Pernambuco. You guys, I think you didn't understand anything. I'm from Brazil, and I traveled all the way from Recife to Cleveland. That's Recife. That's Cleveland. It was a really long journey. American Airlines didn't help. But I was able to get here, and it was really exciting. So that's my city. It's in the northeast part of Brazil. It's really sunny. It's really hot. So I'm kind of getting cold here. It's really cold for me. But in Recife, we are really sunny and rainy sometimes, but really sunny most of the time. It's a really nice city. You should come visit, please. It's amazing. Give it a shout out, and I'll walk you around Recife. It's amazing. So okay, let's get to the presentation. This is what I plan to talk to you about today, about relationships and what it means with your data. Then we are going to go further into graph databases, and I will introduce you to Neo4j. I guess all the people that raised their hands about graph databases heard about Neo4j, right? It's pretty common. I'll give a small comparison between Neo4j and relational databases for those who are not familiar with. And then I will walk through some applications of graph databases. So relationships. So whenever you become friends with someone on Facebook, or you follow someone on Twitter, or you are connected to someone in LinkedIn, this creates a relationship between you and that person, but not only in our real world, but also virtually. Your data is now connected to that other data, like your profile data from Facebook is now connected, has a relationship now with the profile data of that other person. So how can we manage this? How can we manage all these connections that we have now in all the social networks that we have today? I'm going to propose here a small scenario, a social network where a user can be friends with another user and like a page, like Facebook, like the basic features of Facebook. So let's imagine this scenario, and let's try to organize this in a relational databases. How many of you here have worked with relational databases like SQL, Postgres? Yeah, great. So you guys know that relational databases work with tables. So let's create some tables to store our data from our social network. Let's say we will have a table called user that we will store all the information about our users. They have name, gender, and age, maybe. We also need another table to keep track of who is friend with who. So we have that friends with table over there. We also have pages in our social network. So we have a table to store that information. A page has name, has category. And also we would like to store the information of which user likes which page. So we have another likes table over there. Oh, sorry. So okay, now we have our users, you have some pages. So this is a pre-populated database. So let's see what are the pages that the user with name John likes. So to answer that question, we have to go back here and get the ID for the user named John. It's ID1. And then we have to go to that other table called likes and check all the pages that have the ID1 related with. So we have 2 and 1. And then we have to go back to the table page and see which one are those. So we have that John likes Coca-Cola and the Beatles. So we had to join, to answer that question, we had to join information from more than one table. So we had to move from table to table. So how can we improve this process? It is possible to improve it. It is. That's the lead for us to get to know what graphs are. Graph is a data structure, and this is the mathematical model of a graph. Graph is a graph G of any name is formed by a set of vertices and a set of edges. So let me show you how our scenario would look using, instead of tables, using vertices and edges. So the same data that we had before scattered around with tables, now we have in a graph. And it's a more visual representation of our data. The circles represent the vertices and the lines represent the edges. The green circles are the users' vertices, and the red ones are represents the pages. So we have this connection labeled friends with that indicates the relationship between two users, or the likes edge labeled that connects one user to a page to indicate that that user liked that page. So if you want from here to check what are the pages that the user John likes, we can just find the node with name John, and then follow that path, follow that edge to the pages that the user don't like. It's very visual. You can see, you can retrieve that information really directly. So why not use this structure, this visual structure that we have here? Why not use it to actually store your information for your application? And that's where Graph Databases comes to the rescue. So Graph Databases is just a system that stores data in graph structures, which allows the explicit storage of the relationship between the data. With this relationship very explicit, like this, with this connection, with this line connecting the nodes, we can get a direct information retrieval from our database. There are also other advantages of graph databases. They also allow a more elaborated data analysis using common algorithms known in graph theory area. How many of you have heard about graph theory or have studied algorithms that uses graphs as the data structure? So yeah, with this kind of research field, with these kinds of algorithms, we can get some really good information from some really good knowledge from our data that using a relational database would be kind of hard to do. So we can get community detection, we can have pattern recognition, we can calculate some centrality measures. By the end of the talk, I'm going to give some examples, some applications that used some of these algorithms that got some really nice insights from the data. Another advantage of graph database is that it has a flexible data model. So they allow the insertion of new entities, new type of nodes, new type of vertices, new type of connections, edges, without the need to redo all the databases. So you have already existing database, you then go in, let's say we want to add the concept of group in our social network that we had before. We had user pages and now you want to have groups, group of discussion. So here we have our existing database, we then just need to add a new node, say this node is of type group, and then create a new relationship label. That easy. Another advantage is that the recent graph databases that we have available today, they perform using NoSQL-based storage mechanisms. So they are really good they are really good performing horizontal scalability. So you can have small machines, more small, cheaper machines running your database, and we can get like a distributed processing of this database in several machines. Okay, so now we know what a graph database is, and I'm going to talk to you a little bit about Neo4j. Because why did I choose Neo4j? Because it's the most popular graph database according to the DB Engine website. This is a website that lists all the information about all the databases available today, and it's the most popular graph database that is known. It is implemented in Java, and it has its own query language, that's Cypher. So those of you who are used to work with relational database, you know SQL, I guess, really well. And so Neo4j doesn't work with SQL, it works with Cypher. And the data in that database can be accessed through a REST API or through a Java API. But we also have libraries that manages this connection, especially with Python too. So let's take a look at some examples of creating a vertex or a node, how we also call it. You can call vertex or nodes. How we would create a node using Cypher. So we could submit this create a node. This is the syntax to create a node, and then we say after the columns, we say the type of that node, and I'm saying that the type of this node that I'm creating is the type user. And following that, I can pass all the parameters that I want. I want to create them with a name, with a gender, with age. I could create them with social security number, with whatever you want. You can pass all the properties that a user has between the presets. And then here I'm just asking to return the node so I can see that it actually created. So once you install Neo4j on your machine, we have like a community version of it, and you can install for free and play around with it. As soon as you do that and you run it, it will open a browser interface for you to play around and submit some Cypher queries. So if you submit this query there, this is the result that you would get. You will get, this is the graphic interface for Neo4j. It's really, really nice, and you can see all the nodes. And this is the node that we just created. It's a node named for the user, John. That's simple, but how we would receive that if we want to create through the API. So we would receive a JSON object back, and inside of this JSON we have a graph object that lists all the nodes and all the relationships that we have in our database. So our database was empty, and now it has only one node. That's for the user John. So now let's create a relationship. Let's say that I have already two nodes in my database, one for the user John and another for the user Mary. So first I'm matching these nodes. That's the keyword match over there. And I'm getting those two nodes that are for the type user, and I want the first one to match the user with name John, and the second one to match with the user with name Mary. Once I have those nodes retrieved, I can then create a relationship and label this relationship with the label friends with to indicate that John is friends with Mary. And I am returning the result of this relationship. So before we had those two nodes separated in our database. You could also access them, but now we created a relationship between them, having this edge that goes from one to another. Sorry. And as I mentioned before, we can have a JSON object as return when we access them through the REST API. And now our graph object has two nodes and one relationship in the list of our JSON object. That's really cool. So now I loaded all the data that we had before in those tables in that first scenario that I showed you. And I loaded everything to Neo4j. And this is what our database looks like now. We have 3 users and 3 pages and all the relationships between them. And now we want to ask the question, what are the pages that the user John likes? How we would retrieve that information? So we match the node user that has the name John. And then I want to get all the pages that are connected to that node with the label likes. And then I'm returning this. So this is the result. I can get that information pretty easy. And I can look. I have a visual representation of that question that I was asking, the user John and the pages that he likes. In the REST API would return a JSON like this with an object data that would return all the rows for our query. So the first one is from John to Beatles, the page Beatles, and the other one is from John to the page Coca-Cola. Okay, but this is fine. This is cool to play around with and just checking how Neo4j works. But how could we integrate Neo4j, this database, to our Python application. So this is where Py2Neo comes in handy. So Py2Neo is a Python module that works with Neo4j from applications or for command line. It supports both Python 2 and 3 and supports, oh, sorry, it's a typo there, CPython distributions. So now let's try to recreate those examples that I showed you using Cypher. Now how we would do the same thing using the Py2Neo, using Python to do that. So here I'm accessing the graph and I'm passing the password over there. And then I start a transaction, just as we would do transactions in a regular relational database. So we start a transaction and then we create a node object telling passing what's the type of that node, and then all the parameters that the node should have. And then we create the node, and then we commit all the changes that we have done before in the transaction, and it gets pushed to the database. And now our node is created. Same similar thing happens with create relationships. Suppose that we have already a node named John and a node named Mary, and then we just create a relationship object with these two node objects and give a label to it that's friends with, and then push all the changes to the database. And how would we answer that question to get the information of what are the pages that the user's John likes? We can have this node selector object, and then we can select a node based on the label and on one of the parameters of that label. So from the selector, we call the function select. We pass what's the label of the node that we want to select from the database, and we pass the parameter that we want to match. So we want to match the user with name John. And here, since you can have more than one John in your database, we are getting the first one that is returned by this list. And then we are matching, we are getting the graph, and then we are matching all the paths that goes from John, that's John is the start node, and goes through paths that are labeled as relationships likes. So we are getting all the end nodes that are at the end of this path. And over there, I'm just going over these results and printing, and this is what you would get if you run this program. You would get 2 page objects and their properties, the category and the name of the page. So now that we are good, we can start thinking about, it's not that complicated to start using Neo4j. There is a line curve to learn a little bit of Cypher, because it's not quite similar to SQL. And we can integrate this to our Python applications using Py2Neo. But let's compare, actually, Neo4j with relational databases, just the ones that haven't the chance to work with Neo4j has a better idea of the differences between them. So I brought here the same query that we've been working on, the pages that user John likes. I already showed you this Cypher query that we had at the beginning, 2 lines of code, very easy, very simple to retrieve. But if you want to get the same information with SQL, using that structure that we had before, we would have to go through a lot of more line codes to do that. We would have to select from where, do some table join over there to get this information. So, I mean, SQL has more, you have to inform more to get that information. But this is not like, this is really great to have Cypher to help you retrieve that information, but we have to be conscious of the pros and cons of using a graph database. So for instance, this is an experiment run by, I think it was uh, Mississippi University, I'm not sure, sorry. But there is a link in the presentation to the article that released this experiment. And then what they did was they want to compare the time that that MySQL and Neo4j would perform two different kinds of queries. One is a structural query that would be more like a depth search into your data, like going from node to node. And the other one was just a data query, like give me all the nodes that have this property above a threshold, like a simple query that we do usually. And here they show that for a structural query, that the one that you need to navigate through your nodes, Neo4j performed better because it took less time to respond to that query, while MySQL you had this overhead of answering a structural query. On the other hand, for data queries, we see that Neo4j falls way behind. So MySQL is very optimal for this kind of query. So what you should pay attention to when deciding if you want to move to graph databases or not is what kind of query are you going to be performing, or what's the structure of your data in the real life, if it makes sense for you to have them in a graph databases, because you can't be like hype-driven development, right? You need to understand what's the purpose of your application, and or else you could get something like this, like you use graph databases, but you do like data query that's not really optimum for Neo4j, and then your application performance goes down. So that's my piece of advice for you guys. So now that I talked everything, let's see some applications. I brought you 2 examples of applications using graph databases so you guys can have a better idea of where it's applicable. First, there are several areas that can benefit from graph databases, especially social network. That's the example that I've been using during this presentation. Also bioinformatics. I'm not from this area, but I've known a lot of people that wants to work, works with bioinformatics and really could use graph database because molecules and particles are connected to each other, and this connection gives some information, and that's important for them, for their kind of research. Also genetic analysis, this connection between the genes, it's important too. And communications, like phone companies, internet companies, they could use this because they have hubs of communications and towers, and they could see this information better in a graph database because they could see the users that are connected to a certain hub and a certain proxy, and they could manage better their network of towers, basically. So about to you 2 applications. The first one is a really interesting one about corruption in Brazil. I don't know if you guys know it, but Brazil is really bad at this corruption perception index brought by Transparency International. We are orange. That means that as the more red, the worst, more corrupt the country is. So you see that Brazil is not that good. It's really bad. And there is this journalist in Brazil called Leonardo Salas, and he researched with the data to find out how the Congress, Brazilian Congress, is indirectly kind of contributing to deputies' campaigns donation. It's really interesting. This is the link for this article. It's in Portuguese, but you can kind of see the images. The images speak for themselves. So, what this application is? We have each congressperson in Brazil. They receive a unique amount of money to pay for expenses related to parliamentary activities. Mark that part. Exclusively parliamentary activities. So they would pay for, like, I don't know, some office supplies, stuff like this that they need for their parliamentary activity. It's a lot of money, trust me. So what Leonardo did was he did analysis over all the Congress expenses from 2013 to 2017, and he cross-related those expenses with the campaign donations for the deputies for the 2014 election that we had in Brazil. All this data he took is available at the Congress Transparency Portal. In Brazil, we have pretty decent transparency portals for the public services that we have. The data is not very well formed. It's really hard to get some information. If you guys are interested in this kind of analysis, also Turicas is one of the guys that are here. He gave a talk yesterday about this too, and you can tweet him about this because he really knows how to get this information from these transparency portals. His work is amazing, and he helps a lot of the journalists, including this one. And for this analysis, Leonardo used Python with Network X. It was not Neo4j, but it was Network X, another Python library that you can just organize your data in a graph model, but it's not a graph database. It's just in memory. So what Leonardo found out is that he found these circles in the graph that he had. So Silas Câmara is one of the congressperson that we have in Brazil, and that huge number is the ID of a company. And what happens is Silas got some donations from that company during the election of 2014, and after that, he kind of paid back the donation that he received, a lot more actually, paid back to the company and it was paid using public money through the Congress expenses kind of thing. So he found out this using graph analysis in a graph structure that he had this data in. He also found out another kind of structure where one congressperson got donation from one company, then paid back using Congress expenses to another company, but that other company donated to another congressperson, and then that congressperson paid back to the first company. So they kind of, not directly, it was indirectly. So this is kind of an interesting result for us to see that actually the donation that they are receiving, it's kind of paid back with our money, with taxes money. And that's not good. So it was a really interesting analysis that he did using graph structure for his data. It was really good. But let's talk about some other applications. Not as serious as this one. It was a really good application. But for me, it's really serious. It's Game of Thrones. It's really serious, come on. And this is really interesting. There was these two guys. I think you guys heard of it. It was pretty big. Graph of Thrones, the guy's name. I found it amazing. So these two guys called Andrew Beveridge and Shan. Sorry if I mispronounce it. They kind of analyzed a network formed by all the characters of A Storm of Swords, the third book in the series. And what they did was they find out all the interactions between characters of the book and gave a weight. Like, if two characters just said like hi, it was like a small weight. It was not that big, but it was like Jon and Daenerys. They kind of went down to it the last season, so the weight would be really big, I would say. So those guys did this to all the characters of the third book. It was like an amazing work. And they had a table like this, with the source, the target, and the weight of the relationship between the characters. And William Leon, he loaded the data to Neo4j and ran some analysis onto it. So it was really good. And this is also there is a link to the article of William Leon where he showed his work. It's really good. I recommend you to read it. So what William used was iGraph. iGraph is a Python module that allows graph manipulation using known algorithms such as centrality measures and community detection. So what he did is he loaded all the data to Neo4j, and then he retrieved that data using iGraph, and then ran some algorithms, some analysis using the iGraph facility. So this is the code that I took, some kind of code that I took from here. And then what he did is he ran this query, the Cypher query, that now we know it's a Cypher query. He ran that to Neo4j, and then he retrieved all the data, and then he ran a iGraph method called community walk trap to kind of detect all the communities of the graph, and then created some clusters. And these are the clusters that he found. So he named the first cluster number 1, number 2, and so on. And then the output would be a list of all the characters that belongs to that cluster. Of course, these, for the ones who already studied graph theory, they know that's not always precise. This kind of algorithms, it's not very deterministic sometimes. And of course, we have like Lancel over there by himself in a separated cluster, but this is like an outliner. It's not quite correct, but the other ones, you guys will see the results that he got from it. And then, after he did this community detection, he also used the weight of the relationship between the characters to come up with this graph that he created. And it's amazing because each color represents a cluster. We have like Lancel down there alone by himself. And also we have the size of the nodes. The size of the nodes represent the centrality measure of that character. So it's kind of the degree of importance of that character. And the thickness of the edge between two nodes represent the weight of the relationship between those characters. So here, for the ones who watch Game of Thrones, can realize that this green part here is the Daenerys cluster. We have Daenerys, we have Viserys, Rhaegar, we have Jorah. Oh, I miss Jorah. And then we have blue one is Jon. It's over there. It's all the people from the wall. And over there, the yellow one is all the mass in the kingdom. Like we have Robert, we have Tyrone, we have all the people in the city. So that's really amazing work, and it's available in the link that I shared over there. And yeah, I guess that's it. Thank you very much for listening, and I have questions.
We still have a few minutes for questions. If you have any question, please step up to the mic and ask your question.
Hi, thank you for a wonderful presentation, Nicolle. So I happen to use OrientDB in a cluster at a large enterprise. I considered Neo4j, but I was disappointed that their community edition didn't happen to support cluster deployment. Have you used it in that context before?
No, I haven't. I haven't had a chance to use Neo4j like for production environments, like to scale it up. I haven't. But I actually have heard that it's really difficult, as you mentioned it. I've heard some other people comment to me that it's kind of hard to get the support to do so. Yeah, I'm really looking forward to come to this kind of situation where I should scale up to see if we have other options. I know that we have other options in the market. We have TitanDB. It's kind of dead now, but it has like it kind of shift. But you can also go look for that, and we have other options also in the market that may be the answer for scaling up a database like this. Yeah, but I haven't. Sorry.
I want to say thank you for the talk, and my question is related to if I want to move away from a relational database to a graph database. Do you have any recommendations for how to structure the data so that my data queries don't take as long and I can spend more time making relation queries?
Yeah, so you would need to like organize your data and see what kind of data you should import from your relational to your graph database. Maybe you could work with some, if you really need to run some data query, and it's very common in your application, but also a structural query, maybe we could use some kind of duplication mechanisms, so you can also keep track of everything and make everything like duplicate but in sync, and then go to one and go to another if the data query does not really push down your performance of your application. If sometimes, then I think loads everything to Neo4j and then use it there. But if you really test and see that the performance is going down, then I think duplicate and then work with some mechanisms to sync everything up. So you can run your analysis in the graph. That's really common too. Like you have your operational database in a relational database, and then from time to time you load everything to Neo4j, run your analysis, get your information, get your knowledge new, and then keep living like this. So you have the two sets of information.
All right, thank you so much.
Thank you.
I noticed that Neo4j has its own query language, Cypher. That's what you had said? Yes.
Yeah.
Are you noticing a trend of different graph databases to make their own query language, or to prefer other APIs such as native language API, the Java and REST API type thing, or is there some sort of hopeful trend towards a more structured sort of approach to a general query language that could work for graph databases in general?
Yeah, what I've been noticing is that actually a lot of people went from like rejecting SQL all the way with the NoSQL movement. And now we see that there is a lot of new solutions that try to come up with SQL again. So like they are trying to go back to SQL. And I understand, because either way you would need to learn Cypher, and Cypher can have some pretty tricky parts for you to run a query like performatically good. And I see that there is a lot of shift towards SQL again. I'm not sure if in graph databases we will come up to see one of these. Actually, there is one that just missed the name. I was trying to tell the guy that asked about the scaling Neo4j, and I just forgot. It's ArgoDB. Oh my God, I forgot. Yeah, ArgoDB. They have like this, and the query language that they use is really, really similar to SQL. It's basically SQL extended. They just added a new keyword here and there to work with graphs, and then use that. So I see this kind of shift back to SQL, basically.
One more question?
It's along the lines of some of the analyses that you were showing. So with graph analysis, with the graph databases coming out, what are you really excited about, and like along the lines of like analyses for the social good, like the corruption analysis? Like what gets you really excited?
Yeah. So we had this one. It's really good, and I mean it doesn't use a lot of fancy algorithms, But I also I did my master's using graph databases, and I was really excited about business intelligence using graph databases. So all the vision of dimensions of your application, like product and vendor, and all the dimensions that we have in a company, we could do some kind of use graph databases to run BI analysis in your data, and also run this kind of centrality measure analysis and community analysis. So my research was to kind of join these two worlds, like BI analysis and graph analysis, and we can have everything to one application that could benefit from it. So that's the path that I went to, kind of mix and match with graph analysis.
Thank you.
Thank you, Nicolle. Please help me
Thank
thank
you.
Nicolle.